Hey everybody, welcome to video 7a. This is the start of our new unit, which is on quadrilaterals and polygons. And we started out today in the computer lab or possibly in class, but we were working with GeoGebra. And so I just wanted to remind you that my first page isn't filled in, but you guys already have all of this page filled in. So I did that vocab for you. So we can actually just go ahead and turn the page right to our next piece of our notes today. And what I want to do is I just want to spend a little bit of time talking about the patterns that we observed in GeoGebra today, and to start drawing in some diagonals on some just really quick sketches, you guys. So let's go through here and let's draw us a triangle. Let's draw a square. Let's draw a pentagon. Best you can, doesn't need to be perfect. Let's draw a hexagon. And let's draw a good old octagon, like a stop sign. Okay, so we know as far as the sides, this one has 3 sides. This one has 4 sides. Because remember, that's what we created our slider with. So this one has 5 sides. And here is 6. And this has 8. Okay? So I'm going to zoom in a little bit here because we're going to start drawing in, as you can see here, diagonals. And I want to make sure that you can really see how this is going to work. So for the first triangle there's really nothing that we can do as far as dividing this particular shape into more triangles because it already is a triangle. So we're just going to be able to split this into just one triangle. However, the square here, if we pick a corner, we can divide it by drawing in a diagonal, and you saw on the first page a diagonal is a segment that connects any two what we call non-consecutive vertices. So if I went from this point here to this point, that would be considered consecutive vertices, and if I drew that, I'd just be redrawing a side, so that doesn't make sense. So a diagonal connects non-consecutive vertices, and so we can see this four-sided figure, you guys. It's just divided into 2 triangles. Moving on to our pentagon, you can pick any corner you want. I'm going to pick the one down here just for kicks. And if I drew in as many diagonals as I could from that one point, I'd be dividing it there and there. So clearly we can see 1, 2, 3 triangles in this case. And I hope you can see with the hexagon, dividing that up, 1, 2, 3 diagonals are able to be drawn, but 1, 2, 3, and 4 triangles are able to be created. So we have 4 triangles here. Okay, so thinking about the patterns that you've seen so far, we've got 3 sides is 1 triangle, 4 sides is 2, 5 sides is 3, 6 sides is 4. What do you think 8 sides is going to be? Any guesses? Well, I hope that you can start to see that what we're seeing here, and I'll just draw them in, there's 1, 2, 3, 4, 5 diagonals that can be drawn in, and that creates 1, 2, 3, 4, 5, 6 triangles. In general, guys, what we're looking at is that if we're dealing with n sides, then we are dealing with n minus 2, you can see 2 less triangles each time. And so if we know that one triangle has a sum of the degrees that equals 180 degrees, I hope that this makes sense now why we saw in our GeoGebra exploration today that as we added a side to the polygon size, the sum of the angles in the polygon increased by 180 degrees because it's essentially creating a new triangle each time if you were to add those diagonals in like we've just seen. Okay, So what we're going to do right now is we're going to use this idea and come up with some examples of some formulas for 4 different calculations about a polygon. We're going to be talking about the sum of the inside angles, interior angles. We're going to be talking about just one of those inside angles, if there's a formula for that. We're going to be talking about the sum of the outside angles, and we're going to be talking about just one of those outside angles. And there are formulas, and they're pretty easy to follow through on for all 4 of these. So first off, let's talk about the sum of those interior angles. What we've just seen here is that we can take the formula n minus 2, standing for basically the number of triangles that we can divide the polygon into, and just multiply that by our magic number 180. That's it. That's really sweet, easy formula. N minus 2 times 180. Now, if we're talking about one interior, and make sure that we're talking in that case, only in the cases of regular polygons are we able to just do this quick division. But if we had, let's say, a 6-sided figure, we would put in 6 minus 2 times 180, and we would get 720 total degrees in the hexagon. But we know that the hexagon actually has 6 angles, so we're going to divide it by the number of sides. And that's what you see for this formula. We take the total, which we already know from the first formula, and we divide it by the number of sides. Pretty slick. I'm just going to write that as a reminder here. To find 1, we're going to take and divide the sum by n. Okay, moving on to the next observation that we got from GeoGebra today. Remember, with our Socrative quiz there, we talked about what happens to the sum of the outside angles. And we saw that as the outside angles got smaller and smaller, but there were more of them, no matter what, there isn't really a formula there. There's just a static number, non-changing number that you need to remember, okay? And so that's just 360 degrees. All of those outside angles are all going to add up to 360 degrees. And this is for any polygon. This isn't just for a regular polygon. So just I'm going to put in here, remember GeoGebra. Okay. Last formula that you need in this video here before we start doing some examples with these is for one exterior angle. And if we're just talking about one of the outside angles, just like with one interior angle, we're just going to take and divide the sum of those outside angles by, again, the number of sides. So in this case, that's a pretty quick formula of 360 simply divided by n. So there you have it, guys. These are the 4 formulas that we're going to be working with when we talk about angles of polygons. And you really do, as you can see here in the whisk notes here, you need to make sure that you are memorizing these formulas. Commit them to memory. You will not have them on the next quiz, but you will be asked to work with them and do a little bit of algebra. Okay? The next thing you need to know, you guys, is the bottom part of this page where we're talking about new vocabulary. And you can see that I've put new in quotes because I really don't think, you guys, that these are going to be new words for you at all. But I thought it was worth reviewing just what all of the polygon names actually are. So obviously for 3 sides, we know that's a triangle. For 4 sides, that's the whole idea of what this unit is based on. 4, the prefix is quad, and so it's a quadrilateral. That's how we say that. For 5 sides, think about the armed services here in our country. That's the pentagon. 5 sides, 5 branches. 6 sides is a hexagon. And I always think of the X in hex, just like the X in 6, so that's easy to remember. Number 7 is one that some people struggle with. It is heptagon, H-E-P-T-A-G-O-N. 8, hopefully we know, is octagon. 9 you might not be familiar with, but I think you'll be able to remember it. It's kind of like the letters that make up the word for 9, only it's non-agon. So you've got your two N's there, just like in 9. 10 is a prefix that you've probably seen in science classes or in other math classes. It's decagon. 11, if you think of taking 1 and adding to the 10, it's uno or un decagon. We don't actually say uno, but I think that's easy to remember. The uno is 1 plus deca is 10, so undecagon. And then finally dos or dodecagon. Past that, you guys, past 12 sides, they don't really have special names. They're just called, so a 13-sided polygon is just called a 13gon. A 27-sided polygon is just called a 27gon. Hyphen with a G-O-N. Okay, so that's just kind of pretty much how they all go from that point on. That's meant to be ... sorry. So that pattern continues. Okay, so those are the special names of your polygons that you need as we do the next examples. So here we are. These are the examples from your textbook. In example 1, we're talking about the interior angles of the regular polygon. So as we read through these word problems, which will be described to you in words, it's important to make sure you highlight and kind of zero in on the correct words to set up the correct formula for yourselves. So as I read through this one, the benzene molecule C6H6, and yes, I know those should be subscripts, sorry, consists of 6 carbon atoms, so that's an important probably word there, in a regular hexagonal pattern. Oh, there's another clue, with a hydrogen atom attached to each carbon atom. What we need to do is we need to find the sum of the measures of the interior. So from all the circled information, hopefully you can get that n is equal to 6. And hopefully you can realize, because of the two words sum and interior, if you flip back to the page before here and look up which formula we're using, hopefully you'll agree that that's the n minus 2 times 180 formula. So if I have 6, then I'm just going to stick and substitute 6 right in. 6 minus 2 times 180 is really the same thing as 4 times 180, and so my total degrees of the interior angles is 720 degrees here. Pretty slick. All right, example 2, the sides of a polygon. As we read through this problem, it says the measure of an interior, and I'm going to circle both of those words. And remember means just one interior angle of a regular polygon, they say, is 108. So remember, is the same thing as an equal sign in a word problem. So I can take my formula for one interior, which is n minus 2 times 180, all divided by, remember, the number of sides n, and I can set that equal to 108. At this point, you guys, what we have is definitely a proportion, okay? So we're going to treat this as a proportion by creating a 1 underneath the 108 and then cross multiplying. So we've got n minus 2 times 180 times n, or excuse me, times 1, which really doesn't change anything, equals 108n. Next step I'm going to do here is I'm going to distribute this 180. Oops, sorry, I'll move that back for you. I meant to do this, distribute the 180 to both parts, and when we do that, we get 180n minus 360 equals 108n. Putting our like terms together and moving our variables onto the same side of the equation, we would subtract this 108n to both sides, and I think you will agree that we will land with 72n on the left-hand side, and moving the 360 over, a positive 360 on the right. And we solve, and we get, that should be 72, sorry, we get that n equals 5. So this is a pentagon that we're talking about, where the interior angle is 108 degrees. Next example is interior angles here in this diagram that's given to us. What I can do to start this problem off is realize that this is a four-sided figure. So I'm going to be working with an n value of 4 here. They want to know, find the measure of each interior angle. Well, we're going to work off of first what we know is that the sum of any four-sided figure's inside angles is our magic number 360. And if I add up the algebraic pieces there, I've got x plus 2x plus another 2x plus x, so that's the angles A, B, C, and D, are going to add up to 360. And adding like terms, I've got 6 of those x's equals 360, so my x is 60. Remember, what I was asked to find was the measure of each of those angles. So if I say the measure of angle A, the measure of angle B, C, and D. Now just substituting in each of those values, I hope you can see A really quickly is 60. Measure of angle B is 2 times the x, or 120. C is the same as that, and D is back to being 60. So that's what we're looking for our answers here. Last example, and then you guys can go ahead and do the on your own page. That's the only on your own page you have for homework tonight, remember. You do need to do the notes on 7B1, but there isn't an on your own page for that one, so just make sure that you keep working on the next video. We're almost done though, so now we're talking about exterior angles in example 4, and we're going to find the measures of an exterior angle and an interior angle of a convex regular octagon. So at this point we have 8 sides, so we know our n is 8, and if we're finding, again, an exterior means that we are finding just one of those angles. So remember, that formula means 360 divided by n. So 360 divided by 8 is very quickly equal to 45. So there's my exterior. And if I want to find my interior, remember, my interior is just the same thing as 180 minus my exterior. So my interior angle is 135. That's all she wrote for this video, guys. See you later.